Hello everybody. In this movie we are talking about the join, and the SQL join class is used to combine records from two or more tables in a database. A join is a means for combining fields from two tables by using value common to each. And there are four major joins: inner join, left join, right join, and full join. Let's see what is the meaning of the join between more than one table. At the beginning, I simulate the join with the visual Foxpro commands, and to get imagine of the join before we use the SQL commands. And let's try together. Select order, table order will be selected. The index cost ID will be active with set order 2 commands. Browse last, no wait, shows the table orders. And select customer, the second table. Set the order again on cost ID. Same field is common in both tables, and make a relation between common field cost ID into orders, because selected database is a customer as a parent. So first relation connect the parent table to the child table. The child table ordered before on common field. Here is the cost ID, and with the browse command, the selected field, selected table will be browsed. So let's copy these commands together and paste in the command window. If I select all and enter, the selected commands will be executed by by. So let's see. Here the relation made from the customer to order according to the relation, according to cost ID. So let's see the both table. Here is table customer and order by cost ID. When I move a record pointer to the parent table, here parent table is customer, the corresponding records in the child table will be shown in the next window. For example, for this customer, there are some orders, same customer ID. The next, for order, the next, and with moving the pointer to the customers, the corresponding orders will appear here. So I want to use the join command to make a query, some fields from the parent table and some fields from the child table. Let's see two customer ID named Paris. For example, here there is no record corresponding for Paris in the order table. So when I click here in the child table, the record pointer moved to end of file marker. End of file is after the last record in the file, the end of file switch will be on. And if you try to move the pointer after the last And also there is another function named big enough file, or BOF, if you try to move the pointer before the first record. So for example, for this customer ID, if I click here, you can see the record pointer 43 from 1078 records. And I can move the pointer here, record number 408. And for this customer, there is no order. Another is, let's see in a W here, Winca. There is no order in for Winca. So two customer, there is two customer in the this example with no orders. With this imagination, we try to solve some problem. Let's see the join. First, the inner join. The inner join in this example, in this imaging, you can see the most frequently used and important of the join is inner join. And we also say equi-join, because only the records, the common records between two tables will be joined together. And the query compare each record from left table or table 1 with each row from the next table or table right to find which satisfy the join predicate. Let's see example. Here is the syntax. Select from table 1 some fields, from table 2 some another fields, from table 1 as a parent, and inner join to table 2 as a child based on a common field on common field from table 1 equal to common field from table 2. Okay, let's run this query together. Select cost ID from customer, company, address and city from customer. Again, cost ID from table order is different. The first cost ID comes from table customer and the second cost ID comes from table order. And order ID, order date and order amount from table order. So 8 fields selected from table customer as a parent, and with inner join to the child table. Here child table is order based on cost ID from customer equal to cost ID from order, and order by cost ID. Let's see the example. (1078) records fetched, and in this example, as you see, retrieve without two records with cost ID Paris and Winca, because for these two cost ID no common records in both tables. If I move the pointer here to Paris or use Ctrl F to find something like this, no Paris here. PRPE, no Paris here. And again, no WinCA in W, in range of W records, WinCA, VA, VE, VH, and VL, no WinCA. So table parent, here is a customer. I click on the customer, 92 records, and orders 1078 records. So the join records will be 1078 records, but there is no records for two of Paris and WinCA. Okay, here was the example for inner join. The next join is a left join. Left join returns all rows from the left table. Here is a left table or parent. Even there are no match in the right tables. All records from table 1 will be fetched, plus match values from the right table, plus match values from the right table. Okay, let's see example here. Left join retrieve all records from the table on the left side of the join, and only those records that match the join condition from the table on the right side of the join. So in this example, same query, only I change the inner join with left join. Other is same. Let's see the result. Here, as you see, 1080 records come, including 2 records with cost ID Paris and WinCA, because customer here in the left side, all records selected. Let's see here for the Paris, LMNOP, PA, here is a Paris. There is a 4 null value for the fields come from the another table. Another table here is the order. So because there is no order for the Paris, the fields assigned with null value here. And the WinCA, let's see the WinCA in the W range here. Again, 4 value assigned by null. Okay. The next join is right join. Right join return all rows from the right table, even there are no match in the left table, plus match values from the left table. All from right comes, plus match values from left. So let's change the parent and child between this relation, and let's release the relation, set relation to release. If I select the parent customer here with set relation to with no key, the relation will be released. And in this command, select customer, set relation to means release the relation, browse, select order as a parent. I change the position of parent and child, and set relation order into the customer and browse. So here order is parent, and for each order there are some records as a customer. Let's change here. How many records in order? 1078 records in order, and 92 records in customer. So with moving the pointer to the order, the customer will change here with corresponding customer. Here is a relation many to one. Relation from order to customer is many to one, and customer to order was one to many. And let's see the SQL command. Same query, just I changed left joint with right join, and here is the parent table is the customer, right join with the order. So the right table here is the order, all records fetch from order, and just corresponding records comes from the left. Left here is the customer. So the query is 1078 records without two records with customer ID Paris and Winca, because there were no order for these two customers. And let's see the full join. The full join combine the result of both left and right outer joins. The join table will contain all records from both tables and fill in nulls for missing match on the either side. So let's see here. Let's find the two records, only two records in customer with no order. There are two functions, end of file or begin of file. End of file return true if record pointer reach to the end of the table file. And if you try to pass the record after the last record, the end of file will be true. And BOF is the same, but it compares with the begin of file if you want to move the record pointer to the position before the first record in the table. So I use browse for. In Visual Foxpro we can use for instead of where condition, and here is a condition is end of file order. The parent table, here I select the customer as a parent, and I want to change the relation first. I change the customer as a parent and relate it with the order as a child. And so with moving the pointer to the customer table, the records in the child appear, and with the function of end of file I can browse for end of file order. Means if the parent be customer, and the parent will relate with the order with this command, only those records will appear that there is no corresponding child records. So only those two records appear, because in the child table end of file marker will be true. When I try to move the pointer in the parent, the pointer to the child is only to the end of file. So the end of file true only for those two records. Let's have same result with the SQL command here, and with full join. Select customer. Let's see. Yes, here is two customer, and select from customer 8 fields. Full joins means both sides of table from left and right. On command key where orders means child. Cost ID is null. Is a standard keyword in SQL, and if you run this query, same with the last command I executed. Here is a query. Let's see. Join two table, all records from left, all records from right, but the only records with null value in cost ID in the parent. It shows only two records. Same command in SQL. I showed you both way to reach to those two records. So let's back to the full join with no where clause. Here 1080 records will fetch, because 1078 plus 2 records means 1080. Let's run. Here the records is 1080. All records from left comes, and even you move the pointer here to the bottom, P Paris here, but the cost ID is null. Cost ID is null. And again, WinCar here, cost ID is null again. WinCar. Yes, here is the WinCar with cost ID with null. So I hope you understand the difference between the full join, right join, and left join, and maybe you must need one more time the movie to have a better understanding of the examples. Thank you.